Good morning to everybody. On behalf of QCrete Admixtures India Private Limited, we would like to speak something on chemical admixtures, which have become a very important and integral part of concrete in this modern age of construction. Before we start talking about chemical admixtures, we need to know some of the basics which are very important for any concrete technologist or any QA/QC engineer who receives concrete, produces concrete. One of the most important point which we need to remember always in QA/QC of concrete is the importance of water cement ratio. We all know that water cement ratio is key to strength, all engineering properties, and we know also that the strength of concrete is inversely proportional to water cement ratio, and permeability is directly proportional to water cement ratio. Most importantly, we need to know that we put extra water, even though we require about 0.27 or 0.22 for cement to undergo hydration. We put about 0.4, 0.35, whatever it is, based on our convenience. This is called water of convenience, and this water goes on evaporating at all temperatures above 4 degrees, and at higher temperatures, higher wind velocity, lesser humidity, the evaporations are greater, and whenever this evaporation is taking place, the capillaries are formed, and these capillaries are like tunnels which pave way for materials to come in and get out. And these capillaries, along with other pores in concrete, which are inherent characteristic of concrete, like gel pores and other pores, micro cracks and things like that, make the concrete more porous, of lesser strength. More the capillaries, lesser the strength. More the capillaries, lesser the durability. So we need to somehow manage the capillary pores. The capillary pores can be contained by lessening the water cement ratio. The capillary pores can be contained by doing proper curing, especially if it is subjected to high wind velocities and temperatures. Also, we cannot do directly. We need some aids actually, and there comes the role of admixture, or there emerges the most interesting and integral part of the modern day concrete, which is chemical admixture. So since they take a lot of space, capillaries, they act as transit system for water vapor, moisture migration, and we need to remember these two graphs always. Any construction engineer, QA/QC engineer, whoever is in the production of concrete or who is receiving concrete, or in any form if he is associated with construction, we need to always remember these two graphs, where the first graph on the left hand side says as the water cement ratio shifts to the right hand side, the strength comes down. The other graph, which is almost like a mirror image of the first graph, is water cement ratio versus permeability. As the water cement ratio goes up, permeability goes up, and you can see the impermeability is highest when the water cement ratio is 0.4 and below. That is why when you are specifying durable concrete, HPC, etc., people go for specifying below 0.4. Even in case of extreme exposure, means when the concrete structures are exposed to marine atmosphere or severe exposure conditions where chloride and sulfates and etc. are more, or even liquid containing structures or water retaining structures, the specification says you need to keep the water cement ratio lesser than or equal to 0.4. So these two graphs we need to remember, and these governs the quality of concrete that we produce actually. Whatever we do, however we do, whatever the materials we use, whatever the admixtures we use, the central character which determines the quality of concrete and which pushes the concrete to higher level of durability is one and only one factor, which is water cement ratio. Now, can we reduce the water cement ratio directly because we need some optimum cement content? We can reduce the water cement ratio quickly directly, but it will affect the workability, and you can end up making some low slump concrete or zero slump concrete, or concretes which are useful for paver blocks or concrete blocks or some precast elements, and you cannot produce and transport the concrete, and you cannot have a shelf life, better shelf life, where you can use the concrete for 3 hours, 4 hours, something like that. So there comes there emerges the admixture. The other point which we need to remember is why we should use optimum cement content. So we have already discussed that we know that water cement ratio is the governing factor for the strength and durability, and with the lower water cement ratios we can get required strengths which is suitable for our construction, whether it is M20, 25 or M30 or whatever it is. So we can go for reduced cement content mixes with good water cement ratio or reduced water cement ratios to give the required strength. Second point is, when we are talking about OPC, when OPC comes in touch with water, the reaction which is called hydration produces calcium silicate hydrate gel and calcium hydroxide. And this calcium hydroxide is the most vulnerable portion in the body of concrete, as calcium hydroxide is attackable by carbon dioxide, which makes calcium carbonate. Calcium hydroxide is also attackable by sulfates, etc. And hence the durability of concrete is affected by larger presence of calcium hydroxide. So if we want to reduce the calcium hydroxide, which is on the right hand side of the equation, we need to reduce the left hand side of the equation, which is OPC. We also know that at same water cement ratio, many times higher cement content mixes have given lower strengths actually. So if we go on increasing the cement content at the same water cement ratio, after a particular optimum cement content level, the strength goes on decreasing actually. So we need to restrict the use of cement or the content of cement. Fourth point, which is most important point from the environmental point of view, OPC production involves a lot of energy, fuel, also generates CO2 to an extent of about 0.8 to 0.9 tons per every ton of OPC. So we all know what kind of havoc the greenhouse gases are causing to this planet. And in view of that, it is our responsibility, collective responsibility as civil engineers, especially who are involved in the concrete construction, concrete production, and concrete specification, to discourage the usage of OPC as it is today, as it is produced today, as it makes huge amount of carbon dioxide, emits this greenhouse gas to an extent that 6% of the total carbon dioxide produced in this world is by cement companies. So we should have a cap on the CO2 productions from the cement companies. So if we reduce the usage of OPC, we are doing a great contribution to the protection of our planet by reducing the carbon footprint on the concrete. Fifth point is every product, every material which is man-made has a tendency to go back to its natural state. So if you look at concrete, cement is the synthetic product or the man-made product. All other products are directly based on a natural product, which is like, for example, just we crush the materials and make stone or sand. So the unnatural portion in the concrete is cement, or the synthetic product which is available in the body of concrete is cement, and it has a tendency to go back to its natural state, which is limestone. Cement wants to go back to its natural state, which is limestone. So it will wait for the other agencies like sulfates, chlorides, water, oxygen, all these materials to attack, and then wants to go back to get back to its natural state. So we need to restrict the use of OPC for this reason. Sixth point is we need to have a control on the OPC content, because every 100 kgs of OPC in the body of concrete increases the heat of hydration by 11 degrees to 13 degrees. So that is why in mass foundations, where the heat buildup is of primary concern, we need to have a total control on the heat of hydration. So the best way possible is to first put a total reduction cap on the OPC that we use. So these are some of the reasons why we should reduce the OPC content in the mix, and we cannot directly do it actually. If we directly do it, as we already discussed, there will be reduction in slump, concrete will become unpumpable, unplaceable, untransportable, and unfinishable. So there comes the entry of this material, the wonderful material called chemical admixtures, which has totally changed the way concrete is being done in the last 8 years or so. The chemical admixtures are defined as a material other than water, aggregates, hydraulic cement, fiber reinforcement that is used as an ingredient of concrete or mortar and is added to the batch immediately before or during mixing. There are other definitions also, where we say the admixtures can be added up to about 5% by weight of cement in the mix, and it is other than materials like fly ash or GGBS, microsilica, metakaolin, rice crash, and fibers which do not fall in this category of chemical admixtures. One of the differences which we can talk about the chemical admixtures is that chemical admixtures function in a totally different way when compared to mineral admixtures. Mineral admixtures totally change the hydration products, the way hydration is done or hydration happens inside the body of concrete. The hydration products are different when mineral admixtures are used. but chemical admixtures function as at surface level are charge inducers, dispersants, accelerators, decelerators of the hydration process, and they seldom participate in the actual hydration process. Admixtures, including water reducing admixtures, have to completely comply with requirements of slump, water reduction, setting times, compressive strengths, etc., which are specified in IS code 9103. ASTM C494 is very popular. So the Indian code, we have some specifications. The admixture manufacturer has to completely comply with these codes actually. Plasticizers and superplasticizers belong to a group of chemical compounds known as dispersants, and their primary function is to reduce water, increase workability, reduce cement, increase strength, improve durability. For producers who is producing the concrete, he can have an optimized mix design. For a contractor who places the concrete, who finishes the concrete, he will get an appropriate workability, compactability, he will get cohesion, proper setting time, and strength development. A designer also benefits with these materials, concrete that will meet special needs for placing and performance. A owner or a client gets the design requirements intended for prolonging the surface life of the structure, and for everyone, for the construction community and the humanity, the admixtures contribute in terms of sustainable concretes. So admixtures are part and parcel of sustainable concretes. So how do they act? Admixtures generally act like dispersants. They do not allow flocculation. For example, what happens when cement particles are there? You add water, some amount of water. Cement has a tendency to flocculate. The particles come together and they trap water, and they trap water. And this water, which is trapped or entrapped between the cement particles, cannot express itself in terms of giving good workability to the concrete. So this is a basic, you can say, the characteristic of cement actually. So it traps the water when you add some amount of water, and hence you will not get total amount of water which is already added to express itself as a fluid material. When you add a chemical admixture induces negative charges, deposits negative charges on the cement particle surface, and when several of these charges are deposited on the cement particles, the cement particles become kind of negatively charged cement particles with unidirection. In same direction, the negative charges will be aligned, and since the charges are same, particles become negatively charged, they move away from each other, and the water which is erstwhile trapped in the absence of admixture is released. So what happens when we add chemical admixture and water? When you are adding water, cement grain undergoes reaction with water and it produces CSH gel and calcium hydroxide, as we discussed earlier. And as the time passes, the hydration products grow, charges, because of both physical and chemical action, the charges become weaker and weaker. When the cement particles move over one another during transportation or placing, the charges, the energy or the charges will go down, and they lose their energy, they lose their power, and the cement particles start coming together closer to each other, and the normal hydration starts. You can see here there will be always a tug of war going on between one set of forces which are trying to set the concrete with the aid of C3A, the other set of charges deposited by superplasticizer or plasticizer are trying to move the cement particles away from each other. So as the time lapses, the cement particles start coming closer to each other, and the hydration starts as normal as it should have been in the absence of chemical admixtures. So chemical admixtures are not new. They have been there for quite a long time. Earlier, we always remember about what the Romans were doing, because in whatever way we see, actually, the historians have not been able to go beyond what the Romans were doing. Actually, even the concrete technologists or the scientists, we are not able to record or document what was happening much and much before Romans were doing. Actually, even though we have structures beyond 5,000 or 10,000 years, like some of them are like pyramids, no? We have not recorded or documented usage of mortars beyond that period, actually. So Romans, what they have done comes as first, actually. So Romans were using blood, Romans were using straw, Romans were using urine or in the mortars. Romans used volcanic ash along with that blood and straw and things like that to make it strong mortar. So in early 1935, plasticizers like ligno-based and naphthalene formaldehyde-based superplasticizers came into existence, or plasticizers came into existence with limited water reduction. Around the same time, one of the first patents was done on SNF sulfonated naphthalene formaldehyde-based admixture. Next step was in 1945, where air entraining admixtures came into being. That is said to be one of the biggest changes which has happened in the history of concrete, which boosted the concrete practices significantly, which changed the concrete practices forever. Then in 1955, plasticizers became commodities. Supers or superplasticizers came into existence around 1966, both SNF based and melamine based. And in 1986, when a lot of work was going on polycarboxylates in both US and Japan, they started using polycarboxylates. And Okumura, one of the scientists who was working on HPC, started working on SCC using polycarboxylate admixtures. Then by 2000, you can say PCs became famous worldwide. Now it is child's play. Everybody is using PCs. Lignosulfonates are based basically on lignin. It is a natural mining material, and lignosulfonate based admixtures are basically part and parcel of water reducing admixture or plasticizers, and gives a water reduction of about 10%. we need to know what are the basic functions of a plasticizer or plasticizer before we move on to the benefits and things like that. The primary objective of using these materials is to improve the slump or make a concrete fluid, to the water cement ratio. One of the examples, like these tables were very famous in 1990s, where people were talking about a reference concrete without admixture and plasticizer, which increases the workability, and a plasticizer again which increases the strength, and a plasticizer which gives cement reduction. So you can see here in this table that whenever we are using chemical admixture, we have these benefits where the strengths are something comparable, except in a case where there is a significant strength increase has happened, where the water reduction has taken place. So in short, we can say, let us say the workability is A, strength is B for a mix. Then if you are adding admixture, you are reducing the water, then you will get similar workability, increased strength. Second case, where the admixture is added, we reduce the water, we can reduce some amount of cement, then you can get the workability, similar workability to reference concrete, and the strength can be similar. Where you get the cement savings actually, where you get the cement savings. Third is where you just add the admixture. Okay, here you want a flowable concrete, fluid concrete. You are not bothered about either economy or increasing strength. Just you want to make the concrete flow in a better way, fill your molds in a better way, faster, quicker. So here you will get increased workability and similar strength. So the entire use of chemical admixtures, which are generally used for any construction, any concrete producer nowadays is using, is based on these three principles. Either we can increase the strength, or we can save the cement, or we can increase workability, or we can do combinations of these things actually. Now, most of the ready mix companies do not bother about these things. We randomly take a cement content, we randomly take a water cement ratio, and then we do a mix design, and then we check whether the slump and strength is we are getting or not. So we are not bothered about how this functioning is taking place and all. We have moved away from that, and we are interested in end applications of the admixtures. Other reasons: reduce cost of construction, achieve properties in concrete more effectively other than these means, ensure quality of concrete during stages of mixing, transporting, placing, during in adverse weather conditions, overcome certain emergencies during concrete operations. These are some of the other reasons why we have to use chemical admixtures. So a description of different kinds of admixtures, types of admixtures has been given in ASTM-C 494. Type A is water reducing admixture, which is a simple plasticizer. You can say a plasticizer which gives a water reduction of about 5 to 12% with a dosage of about 0.3 to 0.8%. So here the main function is just the chemical admixtures will reduce some amount of water, and it can be used, as we told earlier, to either increase the fluidity or increase the strength, or do some cement saving. This is just a water reducing admixture. It will not have any other properties. The next category is retarding admixture. A retarding admixture is a pure retarder which it affects the setting time of concrete. It prolongs the setting time of concrete. It allows the concrete to be transported, placed for longer time. but type B admixture doesn't have water reducing ability. It doesn't reduce the water content in the mix. Similarly, the opposite of this is accelerating admixture, which reduces the setting time of concrete, makes the concrete set faster. We need to remember there is a difference between set accelerator and a chemical which hardens the concrete quicker actually. So a chemical admixture can make concrete setting faster, but hardening means strength gain may be slower, can be slower. But there may be another admixture which can give acceleration as well as strength gain in a faster way. We have to remember B and C. B and C principle is catalyst, where the chemical admixture works as catalyst actually. It accelerates or decelerates the chemical reaction. Type D is water reducing and retarding admixture, which is a combination of A and B. Type E is a combination of A and C. Type E is where the shift has happened. You can say a paradigm shift has happened in terms of usage of chemical admixture, where people started using this kind of chemical admixture for all grades of concrete, where the dosage can be from 0.3 percentage to 1.5 percentage, where you can use from M10 to M50. So here they are also called as high range water reducing admixture type of, where this is basically based on sulfonated naphthalene formaldehyde or sulfonated melamine formaldehyde. Earlier, between 1990 to 2000, sulfonated melamine formaldehyde was particularly famous actually. We had some admixtures going into Konkan Railway, where sulfonated melamine formaldehyde based admixture was popularly used. Many of the structures in Konkan Railway has been constructed with this actually. The beauty of these supers from classified as class F and class G is that the water reduction capability has increased manifold from 5 to 12% of plasticizers, which is WRAs, to 20 to 25% or 30% in case of high range water reducing admixtures. The next version is type G, which is the most popular version for ready mix companies. All over the world, ready mix companies are very fond of this kind of admixture, where you can transport the concrete, place the concrete for up to 3 hours, 3.5 hours, because it has an element of retardation also. It has an element of very good slump retention. It has an element of good water reduction. So type G is HRWRA and retarding and very popular. Most of the ready mix companies, concrete producers throughout India are using type G admixture. The performance of water reducing admixtures based on their basis, lignosulfonates and modified lignosulfonates are up to 10%, melamine sulfonates up to 25% water reduction, naphthalene sulfonates 25%, and the highest has been PCE based admixtures up to 40%. So when we have graduated from lignosulfonates to the latest generation of PCE based admixtures, now high strength concrete, SPC, all have become child's play. Earlier in 1990s, we used to go to the market to convince the customer why he should use the admixture, why he should use chemical admixture, and is there any real benefit in terms of economy? Can he do away with the chemical admixture? Can we use cement alone? And we were trying to convince him about the long-term benefits. We were telling that there is no side effects or something like that by using chemical admixtures, and there is a history we used to tell in 1990s when we were trying to promote chemical admixtures. But now it has become almost a commodity, and simply concrete technologies have started writing numbers like 400 kg, 420 kg cement content, M40 concrete, water cement ratio 0.35, 0.34, 0.6, whatever it is, whatever comes to their mind, they can write and do the mixed design, go to an extent of reducing the water cement ratio up to 0.2324 thanks to PC based admixtures. Now, the superplastizers based on conventional beta naphthalene sulfonate superplastizer molecule has negative charges. We have sulfonated naphthalene formaldehyde, sulfonated melamine formaldehyde, sulfonated melamine formaldehyde, which was very popular in 1990s until 2000 in India, slowly faded off because the slump retention was a case. Slump retention was difficult with this kind of admixture, and the usage has been now restricted to some precast units or tile manufacturing and things like that. And SMF manufacturing and SMF also started becoming costlier. So it has taken a back seat. Similarly, lignosulfonates were very, very popular. There are products which are type D, ASTM C494 type of admixture, plasticizer cum retarder, which was very, very popular throughout India. And lignosulfonate based admixtures also took a back seat in India because we found that lignosulfonate based admixtures are very, very sensitive to changes in the cement properties, and any inconsistencies or any changes in the cement properties, especially when the cement content goes up beyond 400 kgs. There used to be on part of the lignosulfonate based admixtures, there used to be set retardation, or there used to be kind of a air entrainment or things like that. And slowly this has gone out of the market almost actually. And the only products which are now being used popularly throughout India are SNF based admixture and PC based admixtures. SNF based admixture is also going to go out of the market as the novelty introduced by PC based admixtures, because PC based admixtures, we are clearly marking its progress from, you can say, 2010 onwards. There is a quick progress and penetration into the market of this kind of material because of its flexible formulations. You have a lot of formulations which can be made for in the category of superplasticizer, slightly higher water reducing ability and highest water reducing ability. You can fine tune to meet any requirement, whether it is to be used in conjunction with SCMs, or whether we have to use this in conjunction with the latest addition to the concrete mixes, which is higher usage of artificial sand or higher usage of this stone sand or CRF or manufactured sand, where the fines are more. The PC based admixtures have been formulations have been adopted very well in this kind of concretes. So PC based admixtures are slowly occupying and almost you can say eliminating the production or usage of SNF to a great extent actually. SNF, second generation concrete admixture, extracted from pit coal or refinery process, water reduction maximum about 25%, and their chemistry. We do not go deep into this chemistry. We are interested in application of these products. PC based admixtures, as we told earlier, there is a huge shift in the way concrete is done thanks to this kind of materials, because water reduction is highest up to 40%. And there are so many formulations, so many ways the PC based technologies have moved with a lot of research, where the admixtures have gone to different level, making different kinds of concretes, including SCC. Now, PC-based admixtures, unlike the SNF and other admixtures, operate on broad chain lengths and side chain length, where both deposit negative charges, and the total amount of charges and repulsive forces or steric hindrance is manipulated by chemical admixture manufacturer by changing the concentration, changing the molecules, um, tweaking the molecules, and then use of nanotechnology also has influenced the progress of these admixtures. Now the mechanisms, in short, almost similar, but PC admixture operates on steric hindrance, where at a molecular level the deposits of chemical charges give tremendous repulsion, and there is a suspension. These cement particles are suspended for longer time, and you get high plasticity, I mean to say high fluidity, longer retention times. Mixes like SCC and things like that are possible using PC based admixture. Another picture of the same. Now, now one of the biggest changes that took place before the advent of PC based admixture was the invention of air entraining admixture. We need to know what is the difference between air entrainment and air entrapment. Air entrainment is chemically produced air when concrete is made with some chemical admixtures called air entrainers. Entrapment is whenever we are mixing concrete, some air is trapped physically. These are called air entrapment. So the difference between these two is these air entrainment, the air bubbles are smaller, very small, largest maybe 1 mm or just below 1 mm, and then it can go up to 0.3 or 0.2 mm in diameter. Whereas the air entrapment, which is a physical action of when physical action of trapping some amount of air when concrete mixing takes place, here the entrapped air bubbles are bigger in diameter, irregular, spread over all across the body of concrete non-uniformly. Whereas when we are talking about air entrainment, the air entrainment bubbles, air bubbles are seen uniformly in the they are spread in the uniform way in the body of concrete. You can see the uniform spreading of air bubbles in the body of concrete, and you can see this even after say 20 years or 30 years. If you cut a core of the concrete, you can see air bubbles after 20 years or 30 years. Some amount of air will be lost. This air will be lost during transportation. Entrained air will be lost during transportation or placement, during compaction. So what is the use of this? What is the use of this air entrainment is that the biggest contribution of air entrainment is resistance to freeze thaw. When these air bubbles are there, and when these air bubbles are introduced uniformly in the body of concrete by usage of air entrainers, air entraining admixture, which are some of them are natural wood resins, some of them are chemical based like SLES, things like that. Some of them are fatty acids, or some of them are vegetable oils, or combinations of these materials. when they produce these air bubbles and they sit in the body of concrete, and when the water freezes, the volume of water increases. When the water increases in the volume during winter in cold weather conditions, for example, in countries like Europe, etc., the increased volume is accommodated by air bubbles. The air bubbles shrink in volume and accommodate the increased volume of the frozen water, which is available in the capillaries or wherever it is in the body of concrete. When the temperature rises, the frozen water again, ice becomes water. It goes back to its natural position, and the air bubbles also come back to its natural position. So this continuous freezing and thawing effect on normal concrete gives rise to stresses and cracks. The durability will become question mark. In the presence of air bubbles, they accommodate the expanded volume of water and hence reduce the stresses and reduce the cracks. Durability of concretes in cold climates have increased significantly. Most of the structures abroad, especially in cold countries, are made with air entering admixtures. The other benefits of air entering admixtures are the air entering admixtures give increased cohesion, pumpability, lasability, finishability, and the another contribution of air entering admixture is these micro pockets of air fill up the capillaries and cause discontinuous capillaries. It will not allow water to enter into the body of concrete easily, and these discontinuous capillaries will pave way for reduced permeability. So many of the waterproofing admixtures which are popular, which the advertisement or the manufacturer says that it will work at 200 ml per bag, 100 ml per bag, are generally based on air entering admixture, which are generally based on lignosulfonate based admixture. So a lignosulfonate based admixture in combination with some air entering admixture will work as a waterproofer, complies to IS 2635. Another very important usage of air entering admixture is that, let us say you have a very harsh sand, zone 1 sand, bad sand, and you want to make concrete with bad aggregates. Okay, a lot of flaky materials are there. In such situations, air entering admixture holds the concrete together, increases the pumpability, and makes the concrete look like a butter, easily pumpable, placeable. Another important usage of air entering admixture is when you are doing concrete for dams or such big structures where you need to use bigger aggregates, 40 mm, 80 mm, things like that. There also you can use air entering admixture where the entire concrete will behave in a segregated, like a segregated mix, and the air entering admixture holds it together. So some of these are the benefits of air entering admixture. One of the most important point which we need to remember when we are using air entering admixture is the amount of air entering admixture should not entrain air beyond 6%. That is the specification for usage as a structural concrete. If you entrain more than 6%, the effects will be very big. Actually, every 1% of air reduces 5% of strength. So we need to be very careful considering the benefits what we talked about already. How to do a mixed design, proper mixed design with a air entering admixture. So we need a lot of experience and a lot of thinking before we start using an air entering admixture. Air entering admixture is also used to get better yields of concrete. If you use this, the yield becomes better. This can also be used in mortars to make a puffy mortar, good mortar, which also enhances the water retentivity, which is required in for plasters. Air entering admixtures are also added to as a part and parcel for some of these cements like masonry cements. So we have other admixtures like waterproofing admixtures. We already talked about something about waterproofing admixture. The base of a popular commercially produced waterproofing admixtures or lignosulfonate based admixture along with air entering admixture. Then mortar plasticizer also has some amount of air in it actually. The mortar plasticizer should give two properties as we discussed already. One is water retentivity and then water reduction and then some amount of air. These three are important. And also a mortar plasticizer should give some amount of retardation, some amount to increase the shelf life of the mortar or plaster. Other admixtures, you have coloring admixtures, various kinds of iron oxides and things like that are used to give different colors. Then we talk about corrosion inhibitors. Corrosion inhibitors are nowadays becoming very popular as the performance of concrete mixes are becoming the primary criteria and not the strength actually. You know, when the oxygen enters into RCC structure along with water, it attacks the reinforcement bar and the reinforcement grows in size after corrosion up to 6 times in its from its original volume. So the corrosion leads to cracks in the body of concrete, deterioration of concrete, spalling, and it pushes the concrete to be almost the case where the concrete structures have to be demolished or they fall off on their own. So you have corrosion inhibitors. Some of the corrosion inhibitors are inorganic or organic in nature. They can be mixed along with the concrete or they can be surface applied. Some of the materials which are very popular are calcium nitrate. They have been used from 1950s or 1960s and have a good history of about 30-40 years. Now we have the latest kind of corrosion inhibitors called migrating corrosion inhibitors. There are two varieties of migrating corrosion inhibitors. One which can be mixed along with the concrete to improve the corrosion resistance, where this chemical migrates literally and collects itself on the reinforcement bar, gives a passivating layer around the steel rod and reduces the corrosion, delays the corrosion, prolongs the life of the structure. So most of the piles done in countries, Middle East and other countries where there is a lot of problems of corrosion, or even now in India, many of the structures where there is a requirement of high corrosion resistance, marine structures and all, they have started specifying corrosion inhibitors. So next one is we have shrinkage reducing admixture. You have something to influence the drying shrinkage and control the drying shrinkage. So these comes in powder forms, and you know it gives a non-shrink property or a shrinkage compensating property to the concrete and pushes the durability to the next level. We have anti-washout admixtures where whenever you want to do the concrete in water, very close to marine structures, undersea water, things like that, you have to have something to bind the cement content in the concrete actually, otherwise all the cement content will be washed off. So you have some of these materials based on cellulose and things like that, where it holds the concrete in a thick state, viscous state, and it will not allow water to wash off the cement, and sets normally with slight delays, but that doesn't matter actually. So these anti-washout admixtures are special admixtures which are used in concretes for underwater works. You have hydrophobic admixtures where you need to make the concrete pores repelling the water. The concrete should be almost impermeable. You increase the impermeability by incorporation of some of the materials like calcium stearate and things like that actually. So what happens is this kind of materials coats the capillary pores, and it provides a sort of hydrophobicity, means water repellency. And the only problem with this kind of materials is that they do not work where you have a head of water actually, where there is a lot of water standing on the structure. That is, water pressure is exerted on the concrete. They don't work actually. Okay. Then you have surface retarding admixtures where you need to produce architecturally pleasing or aesthetically pleasing concrete. You take this kind of set retarding admixtures. We will coat this on the form liner or form work. Concrete is placed, and next day when you remove the form work, the set retarding admixture, which is used as a surface retarding admixture, it reacts with the surface cement particles. It removes the cement particles, and then you will get what is called as exposed aggregate surfaces. You have foam producing admixtures where some of the foam producing admixtures can be protein based, or all sorts of materials or combinations are there. Some of the proprietary mixes are there where there is a production of foam, generation of foam, and you using a foam gun or something like that, a instrument which can push air along with this foam generated through this chemical action, is pushed into cement mortar or concrete, generally cement mortars, and you have these low density concretes which can be used as a non-structural fill. One of the latest technologies which have been made, which has been made very popular, is crystallization technology, where two kinds of materials are being used actually. One which works on the surface, you coat it on the concrete surface post construction, and another one which can be admixed along with the concrete to make impermeable concrete, or they make a high impermeability concrete. So here this crystallization technology is, these are powder based materials, mostly powder based materials. It has some cement and silica sand and some proprietary materials, secret materials, which activates the cement hydration products, basically calcium hydroxide, and eventually forms more and more crystals. These hydration products, which grow as crystals, occupy the capillary pores and make the concrete more and more impermeable, So this has become very, very popular. Both materials, admixtures, one which can be used pre-construction along with the concrete production, along with the concrete making as an admixture, and the other one which can be used post construction as a slurry applied or coating applied on top of a virgin concrete. Both have become very popular, and the manufacturers say that the activation is continuous. The material penetrates and up to about 50 mm or 100 mm and goes on reacting with the cement hydration products. And as long as the hydration continues, which the hydration of cement set to continue for 30-40 years, as long as some amount of moisture is there. So this crystallization also goes on continuing, and hence the impermeability goes on improving actually. So recently there was a person from Mumbai. He asked one question: can you guarantee the concrete after 18 months? What happens to your concrete after 18 months? What happens? What is the reaction after 18 months or something like that? So be rest assured, with the use of these kind of materials along with the CMs, we can say the strength and properties goes on increasing as the concrete ages actually. So this is an example where this crystallization continues for longer and longer time, as long as the some amount of unhydrated cement particles are there, as long as some moisture is there, as long as some amount of calcium hydroxide is there, this process will continue and growth of crystals will continue. They pack the capillary pores and density increases, impermeability increases. Then we have to help the self-compacting concrete makers. As this self-compacting concrete came into the market, we have another problem where when we use a PC based admixture to make self-compacting concrete, many times bleeding happens, segregation happens, things like that used to happen. And to counter this, we have viscosity modifying admixtures. Some of the admixtures are like based on xanthan gum and things like that. There are various versions actually, which are added at a very low dosages, like 0.01% by weight of cement and things like that, which holds the concrete together in a viscous state. It will not allow concrete to bleed. It will allow to flow in a very systematic way. No segregation will be found. So such admixtures are being used either separately or now some of the companies are blending it together with the PC admixtures. So these there are possibilities of many companies using it as an inbuilt two-in-one admixture. One is a PC based admixture, PC based type G admixture, and it is blended with some amount of VMA. So as any concrete mix you give, normally up to 20 minutes or 30 minutes, the bleeding will be there. After 20-30 minutes, bleeding will stop thanks to this kind of admixture. Earlier, we used to have super bleeding admixtures where the bleeding used to continue for 1 hour, 2 hours, things like that. Now, viscosity modifying admixtures are also used as a slump buster. Actually, it means you want to reduce the slump. In some cases, you add VMAs, okay, on site to reduce the slump. It is also called as a slump buster or slump reducer. Now, since water scarcity is there, a lot of water scarcity is there, and also supervising the people who are curing the concrete is not easy. Other countries, especially in US and Australia, some parts of Europe, self-curing concrete has come into existence where some of the materials like they are called as super absorbent polymers, SAPs, have been used to make admixtures which can be added along with other admixtures And when it is used, you need not have to cure externally. You need not have to do anything like curing externally, because these super absorbent polymers or these kind of materials hold the water within themselves and slowly starts giving it as the concrete ages, as the water evaporates based on the temperature. These materials start giving more and more water to the concrete within the concrete, and then hydration continues actually. So there is no need to cure such concretes, especially very popular in areas where you don't get water, or for example you need not have to monitor, you need not have to supervise curing, like where very critical structures like columns and all, where you need to give utmost priority to curing. These kind of admixtures can be used. Unfortunately, in India, as on today, the cost of these admixtures is costlier, and some of the admixtures earlier, which were some people were trying to introduce, they did not give continuous, consistent results. So the use was not pushed properly. And you have special admixtures for precast concrete where you need to have very accelerated strengths actually, high early strengths, where 12 hours 12 MPa, 12 hours 16 MPa, these kind of strengths are required. Here you need a high degree of water reduction, which is achieved by a PC based admixture, and also an inbuilt kind of a accelerator is put actually inside this, blended with this actually, to enhance the hardening process of concrete, and early strengths are gained actually. You have other kind of admixtures, efflorescence control admixtures, shortcutting admixtures, hydrogen control admixtures are also becoming popular actually. As we said earlier, the hydration is a continuous process. Hydration goes on continuing as water goes on reacting, and it is said that until to reach the core of a cement particle, water to reach the core of a particle, it may take 30-40 years, it is said. So there comes the usage of hydration control admixtures, where in the initial stages the temperature control takes place. Temperature is not raised actually in these kind of admixtures, and as the age takes place, it accelerates the hydration process, and the hydration process is made to maximum actually, means the concretes will reach highest potential of strength which is it is designed for actually. This is very highly useful in high cement content mixes, low water cement ratio mixes, where some of the cement particles sit as unhydrated for a long time actually, because of various reasons. One of the reasons can be very low amount of water which we have already put, and probably which has evaporated. In such cases, these kind of hydration control admixtures, they will not allow water to escape. They will control the rate of hydration, and the hydration continues continuously, and then it also acts like a catalyst to change the process of hydration, accelerates over a period of time. Now, the crystalline admixtures, which we talked about earlier, also has the ability to heal the concrete actually. Whenever a crack takes place, the crystals grow. So most of the crystalline admixture manufacturers also claim to have the self-healing of concrete, or healing properties of concrete, the crack bridging ability of concrete when the cracks are very small. Now what we are speaking about is a bioconcrete, okay, where we are talking about two major types of cracks, cracks in plastic state and cracks in hardened state. Both cracks cause problems if left unattended, affecting directly durability of concrete. You have a lot of waterproofing systems actually, and these waterproofing systems give way over a period of time, leading to water penetration and penetration of other contaminants like chloride, sulfates, etc. into the concrete through cracks, causing huge durability problems. No matter whatever you do, the cracks can lead to collapse. Cracks will open up eventually. It is almost impossible today to ensure 100% crack-free concrete. Okay, and it costs a lot. If you want to do such kind of concrete, it costs a lot at this moment. You need to use shrinkage compensating admixture. You need to use a lot of fibers. You need to reduce water cement ratio. You need to do all sort of tricks to achieve crack-free concrete, along with a very good proper method of curing. In spite of all that, many times cracks can happen actually, which can eventually damage concrete structures. So all concrete structures, especially reinforced concretes, have to survive the test of time against weathering agents, need to be crack-free and made impermeable. So this scientist, Dr. Henk Junkers from Netherlands, worked on the concept of self-healing. So when concrete cracks, it will heal by itself. This is based on what is called as biomimicry, which is imitating life, like a wound on a living organism or a cut on our skin heals by natural process. So Dr. Henk Junkers worked from 2006 to 2015 to develop what is called as self-healing concrete. He said you need bacteria that can survive the harsh environment of concrete, and then concrete is very extremely alkaline. Healing bacteria must wait dormant for years before it is being activated by water. So the technology is you have some bacteria, it gets encapsulated in some capsules, you add it as an admixture along with the concrete while you are making concrete, and then whenever the crack opens, when the oxygen enters, water enters, it reacts, breaks this encapsulation, reacts with the bacteria, and the precipitation of calcium lactate and calcium silicate takes place, and you have these cracks healed actually. So that is the principle. The bioconcrete is mixed just like regular concrete, but with an extra ingredient, the healing agent. It remains intact during mixing, only dissolving and becoming active if the concrete cracks and water gets in. So for this, Dr. Henk Junkers chose bacteria which is Bacillus pseudophirmus, and they thrive in alkaline conditions and produce spores that can survive for decades without food and oxygen. So next challenge was how to have the bacteria active in concrete, but also make them produce repair material for concrete, that is like limestone. In order to produce limestone, the bacilli need a food source, which is sugar, one option. If you add sugar, it is a retarder. In the end, Junkers saw calcium lactate, setting the bacteria and calcium lactate into capsules made from biodegradable plastic and adding the capsules to wet concrete mix. When cracks eventually begin to form in the concrete, water enters and open capsules. The bacteria will then germinate, multiply, and feed on the lactate. And in doing so, they combine with calcium with carbonate amines and the calcite or limestone, which closes up cracks. So calcite or limestone is formed and it fills up the cracks. So it is said to have an effect of almost 200 years. The spores can live for a long time. As I said, it is tested through accelerated tests to live for about 200 years. So in important public structures like flyovers, bridges, metro, water storage tanks, nuclear power plants, defense infrastructure buildings, where durability is of number one importance, you can have this kind of material. At this moment, the product is costly and commercial applications are not too many actually, except in some parts of Europe and Netherlands. So it is in, you can say, in infancy. So here in this particular slide, what we can see, so everybody can see the slide where many of us see letter P actually. This is human nature. We leave the entire white slide and focus on P. all the good things are forgotten. It applies to human beings as a whole, how they function, how they work, what they see. We focus only on some negative things. We forget the entire background white thing, and we will focus on some small some speck of this P actually. This is how our perception is there in this world. We see the world like this actually. Similarly, on admixtures, we have spoken so much and we have talked about the benefits of admixtures so far. But whenever small problems happens, we start talking about badly on the admixtures. We blame the admixture manufacturer. So what are the precautions to be taken? Precautions to be taken are very simple, but never practiced actually. Set retardation is a common problem in for any concrete producer or many of the ready mix companies, generally caused by more dosage if the calibration is not done or something like that. Some of the cements may have low C3S. Some of the cements may also have low C3S to C2S ratios. Some of the cements, if it is older and if it has already absorbed some amount of moisture, and if you are adding a type G admixture and at the same dosage which we were using earlier, then also it can cause retardation. Some organic matter can cause set retardation. So we need to be careful about these things actually. One thing we are very sure is earlier days, for example, consider some of the cases which happened in 1993 to say 1996 or 98 actually, where lignosulfonate based plasticizer cum retarder were used actually. So in Delhi, we had seen a girder was cast and the concrete did not set for almost 1 week actually. The concrete can be taken, scooped out, and we can recast the cubes after 3 days. More number of cubes were cast actually, but we could not dispose. The company could not take away the girder, and even the contractor was not interested in taking away the girder which was cast actually, and because it was a crowded area. So we waited for almost. We started taking extra cubes from the same concrete actually, which was cast actually because of the severe retardation, and slowly strength gained actually. We tested up to 3 months actually. The concrete gained strength eventually. So these were some of the bad effects of retardation caused by lignosulfonate based admixtures, which could not operate in higher cement contents and could not operate when the changes were taking place in the cement compositions. So they were abundant actually. But there are many other cases where set retardation has taken place for 24 hours and the strength gain has happened after 7 days and 28 days. And in many of these cases where the set retardation has taken place, surprisingly, the concrete which has retarded has gained strengths higher than normal concrete, or normally if the concrete would have set normally, what strength it would have gained. More than that, the retarded concretes have given the strengths. One of the scientists, Vance Dodson, explains that by simply comparing the work of two masons, one who is building a masonry wall faster, and another who is building a wall very systematically slower. And when the hydration is set to go slowly, it is set to trigger better reactions, better hydration, and strength gain in such concretes, retarded concretes is said to be better actually. So we have experienced this one. So some cases where there is a retardation happening actually. So we need to give time. We need to give time for that concrete to settle, and we need to give time for this concrete to gain strength actually. In our quick race, we have this tendency to just yell at the vendor, yell at the ready mix company, shout at the admixture manufacturer, and tell them, "Oh, you demolish this concrete at all. I don't want this concrete." Okay, we want the lowest cement content. We want everything best, but we can't just have some patience. So in such cases, you have this set retardation problem will become really a problem. So some people will become really panicky if there is a set retardation. But as per our experience, we can assure that there is no big problem if there is a slight delay in set retardation. You need to give time. You need to give time for the concrete to set. Next one is you have some manufacturers who use air entrainment admixture, who blend it with maybe PCs, maybe with SNF admixtures for various reasons to make the concrete viscous or cohesive. In such cases, we need to remember that higher the dosage that we use, lesser the strength it will become, because more amount of air it will be entrained. So we need to be aware that we need to take care of the density. We need to check the density of concrete continuously to monitor the performance of concrete actually. Slump loss is a common problem actually in many of the concrete producers facility. Slump loss is majorly directly attributed many times without checking anything on the admixture. So we need to remember there are other ingredients. You know, in concrete, admixtures generally, if we take all over India, maybe between, for example, in South, if we take, it is between 0.4 to 0.6 or 0.8, maximum 1% in South. Western regions, the admixture dosage can go between 0.4 to 1.5%. So other 99%, what is happening with the other 99%? Are we maintaining the same 99% when we have done the trials in the reference concrete? We have approved the admixture. Have we maintained the same 99% or not is the question which we need to introspect actually before we talk anything about admixtures. Slump loss can also happen with if the temperature of cement is more, if the aggregates are not sprinkled, if the aggregates are not shaded, if there is more fines than earlier, or during the trials you have taken a good sand for doing trials, whereas when you are supplying the concrete, when you are producing the concrete in large quantities, you might have changed the source of sand where the 150 microns or 75 microns might have increased actually. That also contributes to both lesser initial slump and slump loss. If the truck mix is turning faster at very high RPM, then also it can cause slump loss. Most importantly, if the quality of gypsum used in cement, if it is hemihydrate or anhydrate of cement, it absorbs the admixture. It absorbs the admixture. It will not allow the admixture to work the way it should work actually. In such cases also you have slump loss problems actually. We need to be careful when we are using two admixtures, because some of the times what happens, you have a PC admixture on plant. Sometimes you have another admixture, maybe SNF. PC and SNF are not compatible. You should not mix a PC admixture or any admixture with a waterproofing admixture without doing trial actually. There are some companies, some customers who will say, I want to add waterproofing admixture. Okay, so if we just directly add, you may end up in set retardation, as most of these waterproofing materials are basically based on lignosulfonate based admixture. They have probably an inbuilt retardation property and air entraining property. So if we don't do trial and don't fix a proper dosage of both the regular superplasters that we are using in conjunction with what is supposed to be used as a waterproofing agent. If we don't fix, then we are going to end up in set retardation or air entrainment or strength loss or something like that. And we also talk about sometimes on heavy bleeding and segregation. So we hear customers telling about heavy bleeding. Heavy bleeding and segregation can happen because of coarser particles, gap graded aggregates, a complete repulsion of admixture by cement particles means cement particles repel water and admixture in a very big way. High amount of charges are deposited. High dosage also can cause heavy bleeding and segregation. So we need to control the admixture dosage, and we need to do one or two trials more with probably increased sand content or something like that to control this. Sometimes we end up in sticky concrete, unpumpable concrete. Mostly it is related to the properties of the admixture. Sometimes you can rectify it by reducing the sand content, but generally we can change the admixture if it is very sticky and it becomes unpumpable. If we have a high slump concrete or SCC concrete or SDC concrete, things like that, and by chance somebody vibrates actually, or a free flow concrete is there, you allow a customer to vibrate it too much actually, then slurry comes on top. So it is not to be blamed on admixture. It is not a problem of admixture. It is a problem of handling on site. And we also hear most of the times inconsistencies of admixtures, incompatibility of admixture. Very easy, very easy for many people to just tell it is incompatible. So what is compatibility? The admixture that we have chosen, that we are using, should be clearly working with the cement that we are using actually. So suppose we have chosen an admixture from a company, and we are using, we have done the trials. If the setting time is all right, strength is all right, slump retention is all right, this material is, this is said to be compatible. These two are compatible. So we have done the trial, the admixture is okay. We have received the admixture barrel also. We have done one or two trials more again. Production also has started in a producer's facility or a ready mix company. And let us say after 1 month, some things change in other ingredients. Let us say in cement or something like that. So we say it is incompatible. So what is the problem? The problem is the admixture is same, but the cement has changed actually. So it is incompatible. So what happens in this situation is whoever is strong, he wins actually. Whoever is strong, he wins actually. Generally, people try to change the admixture because the admixtures and the concrete technology means the chemical manufacturers, they go to the extent of modifying the property of the chemical admixture. They suit for they suit the admixture for different conditions. Okay, so they probably do some changes in the chemical admixture to suit the new consignment of cement. Okay, so in whatever way we want to solve, this can be solved by understanding how the chemical admixture was behaving. Was the chemical admixture same earlier? And if there is a change in cement, these things have to be discussed actually. These things have to be studied. Simply blaming chemical admixture is inconsistent, is not going to solve the problem many times actually. We need to understand, as we are concrete technologists and civil engineers, what has gone wrong with the other ingredients. So when we are talking about usage of chemical admixture, as long as the properties, pH, specific gravity, solid content, everything is within the range initially when we do the trials, and if the admixture company is giving similar solid content, similar pH, similar specific gravity, all as per the IS code, within the limits of the manufacturer. So the changes we need to look is outside the admixture, outside the admixture. One of the most beautiful statements by Einstein. Today, wherever we are sitting, where we're sitting, this point will not come in our life, not only for anybody, for the entire humanity, as the Earth is rotating at a mind-blowing speed of 30 kilometers per second. Sun and galaxy, everything is shifting at very fast rates, and we will not be able to touch this point again in our life, actually. So we should be curious about not only concrete, not only admixtures. We should be curious and open-minded to understand so many other things which are happening in this world. Especially as concrete technologists and civil engineers, we should learn this the behavior of chemical admixtures, and when they are incorporated, how they behave and change the total concrete itself. We should develop this interest, and we should be curious to know more and more about chemical admixtures. Thank you. Any questions are there? You can write the questions. You can ask the questions. If some of the questions you are not able to answer now, if that situation comes, you can also write to me. Before we end up, before we take questions, I thank all of you who have attended, leaving your work. I'm privileged and honored to speak to all of you, and I'm thankful to our company and our MD, Mr. Shelly Fernandez, for giving me an opportunity to speak to all of you. You can ask questions. I will take some questions if they are there. And as I said earlier, if the questions, some more questions are there, anytime you can send the questions to our website, Dr. Q. Somebody is asking Mr. Singh, what is the difference between plasticizer and admixture? Anything which is added to concrete, anything added to concrete can be called as an additive and an admixture. A chemical admixture, which we have described all along through this lecture, is it can be SNF based or lignosulfonate based or PC based admixture. So is a admixture which is added to concrete at a particular percentage. But a plasticizer is which brings plasticity to concrete, which brings fluidity to concrete. So a plasticizer is generally a water reducing admixture, which is generally based on lignosulfonate based admixture or hydroxycarboxylic acid based admixture, or some of the inorganic salts it may be, but it will have a small effect in water reduction, giving a water reduction of about 5 to 12%. It can be used between a dosage of 0.3 to 0.8% by weight of cement. It has a limited activity. Limited activity means limited water reduction. So that is a plasticizer. An admixture can be any category, means it can be a waterproofing admixture, it can be a corrosion inhibitor, or any of these can be an admixture. A plasticizer is a specific category of admixture. answer some more questions through mail. Actually, I will be able to send through mail actually. And thank you very much once again. On behalf of QCrete India Private Limited. Thanks a lot. Thank you.